Hello everyone, I'm Quentin, the CTO of Autoscale, and today I'm glad to introduce you to the assembly script contract framework I developed last year. Let's start with a little backstory. You know that on MultiversX, smart contracts are created in Rust, and those who know me know how much I praise Rust, how much I love working with it, to the point that my hackathon project is based on Rust. But let's rewind. When I first began my journey as a MultiversX developer, I was unfamiliar with Rust. And at this time, my aim was to write simple smart contracts to discover the MultiversX ecosystem. But as you probably know, Rust is a very difficult language. I had some experience in multiple languages, such as Swift, TypeScript, Kotlin, Java, and so on. So I thought it would be easy for me to learn Rust. I was naive, because when you start to learn Rust, you have to understand really difficult concepts, such as generics, and not the same than TypeScript, or the borrow checker. So I was like, do I really need to master such challenging language to write so simple contracts, such as NFT mintings? And of course, after a lot of practice, I became quite proficient in Rust, but this question stayed in my mind. And I know I wasn't alone. Many developers failed the same hurdles, and I'm convinced it deters them to come on MultiversX and build their products. And I saw a lot of tweets saying that the MultiversX virtual machine is super flexible, that we can write smart contracts with any language. And I wondered, how is it possible? So I started to read the code of the MultiversX virtual machine. I delved into it, and that's when I discovered WebAssembly. WebAssembly isn't exclusive to blockchain. It's a binary instruction format designed to be safe, efficient, and portable. The keyword is portable. Usually, when you compile a language, a program with a compiled language, you need to target specified devices, such as Intel-based Windows, Intel-based Mac, an Apple Silicon Mac, so Mac M1, M2, and so on, an Intel-based Linux, or a Raspberry Pi, which is not an Intel processor. However, WebAssembly offers a universal compile target. It means that a Rust program, for example, Rust, compiled to WebAssembly, will work the same on any devices. And it's a game changer. But let's talk about the MultiversX virtual machine. It's based on Wasmer, a runtime for WebAssembly programs, and in our context, programs are smart contracts. And it means that any language that compiles to WebAssembly can be used to write smart contracts on MultiversX. But what about TypeScript? TypeScript is a transpiled language that's turned into JavaScript, and JavaScript is not a compiled language. It's interpreted by runtime, like your internet browser or Node.js. So it seemed that TypeScript wasn't suitable to write smart contracts on MultiversX, and it was the case. Before the introduction of assembly scripts, assembly script's mission is clear. Develop a language similar to TypeScript, but one that compiles to WebAssembly. Here is a quick comparison. So you have on the left function, a TypeScript code, and on the right, the same function and assembly scripts. This is a classic function that calculates the nth Fibonacci number. And you can see how similar the two languages are, because the only difference is the number parameter. In assembly scripts, you need to specify the length of integer and whether the integer is signed or unsigned. But let's dive a bit deeper into assembly scripts. So you saw that one of its main features is the similarity with TypeScript, but it extends to all oriented object programming principles, because assembly script supports classes, interfaces, and so on in much the same way and with similar syntax as TypeScript. So in essence, if you know TypeScript and you have ever worked with it, you already know and understand assembly scripts. And TypeScript is widely known among developers, so we can say that assembly script too. At this point, you may think that we have all the stuff we need to write contracts on MultiversX with TypeScript or assembly scripts in our case. And from a technical point of view, you're right. But I don't recommend you to do so. By doing so, you will encounter many challenges interfacing the MultiversX virtual machine. Here is why. Imagine only having access to pointers that point to data stored in the MultiversX virtual machine, rather than the data itself. It means that whenever you wish to manipulate this data or perform operations, such as concatenating two strings, you will need to invoke low-level functions, supplying them the pointers, and this function will return yet another pointer representing the results. And this approach extends for all blockchain operations, such as sending USDT tokens or retrieving blockchain information, such as the caller address of the transaction or the owner address of the contract. Consider this example. You have an array with two strings, A and test. In the virtual machine, it is serialized as a buffer. The serialization is a process that globally concatenates the two nested forms of the strings. And you, as a smart contract developer, you only have a pointer. In this case, it's 105. It could be anything else. It's a number. And if you find this a bit confusing, it gets even worse with custom data types. So if you attempt to directly write contracts with assembly scripts, you will need to manually encode and decode the raw data to have the array, and also to manage pointers. And you will focus on that rather than focus on building your products. And that's not what we want. So addressing these challenges requires a bridge between the MultiversX virtual machine and you, the smart contract developer. And this is where the assembly script contract framework enters. I developed the assembly script contract framework a year ago. This is an open source tool to simplify writing of smart contracts on MultiversX. I adopted many concepts from the Rust contract framework that does the same, but in Rust. One key focus when I built this framework was to maximize the oriented object programming concepts. So basically, your contract is a class where public methods are the endpoints and public properties are the contract storage. While it's still in its early stages and not ready for production at all, many features are in place. I have incorporated widely used managed types like managed buffer, big uints, multi-value encoded, managed vec, and so on, along with common storage mappers, single value mapper, vec mapper, map mapper, queue mapper, practice mapper, etc. Developers can also define their own data type like they do in Rust with structure, but in AssemblyScript, this is with classes or enums. And they also can pull information from the blockchain, including the transaction data. Moreover, operations relating to USDT tokens, such as sending, minting, or burning, are supported. I also implemented contract-to-contract synchronous call, so call when the two contracts are in the same shard. Let's look at a simple contract example created using the framework. This is the header contract, a basic contract that lets you increment a number in the storage. So you have on the left the Rust version of the contract, on the right the AssemblyScript version of the contract. They do the exact same thing. It demonstrates how easy it is to create a smart contract using the framework. And if you see at the plus operator in the add-on point, it is a perfect example of pointers handling and low-level call done behind the scene by the framework. You can see the QR code to access the GitHub repository. You will find tutorials, documentation, and a lot of examples. I reproduced a lot of examples from the Rust contract framework, but in AssemblyScript. If you want to contribute, I would be glad to read your ID. And thanks for listening.